We're going to do all of 4-2. Last lesson. Here we go. We're going to do something called implicit differentiation. We're going to take derivatives of other types of things now. Differentiation. Sounds hard, huh?
How would this benefit us in our daily lives?
Ooh, it will, because two things. One, you're going to be better at this when you take it in college. And two, when we get to the chapter on applying these, we're going to know how to apply them. Oh, there's lots of word problems coming up. Yes. Yes. Physics, yeah, of course. But other than physics, like rates of change, it's crazy. No, there's a whole chapter on applications. It's coming. And we do a whole project on it too.
What?
Yes. Flying a kite, boring a cylinder, air traffic control, a sliding ladder down a house, then you're falling, hot air balloons rising. I mean, don't even get me started. Change in volume, inflating a balloon, change in area. Oh, it's exciting stuff. That's second semester, so you're going to have to wait. I know some of you aren't coming back, but you're going to need to come back for that. Okay. All right, so far we have been doing explicit differentiation. I know you didn't know that. We just called it derivatives. But so far all we've been doing is taking derivatives of functions, right? Derivatives of functions, like derivative of polynomials. Those are all functions. But what's not a function? There's lots of things that aren't functions. Are circles functions? No. We can still take the derivative of it, though. But it's called implicit differentiation. Okay. Now, to do implicit differentiation, you have to take the derivative of both sides with respect to x. Now, when you take the derivative of x with respect to x, you get 1. Okay? But the derivative of y is dy dx, or we call it y prime. Okay, so the derivative of x with respect to x is 1, but the derivative of y with respect to x is y prime. So what you're going to do is you're going to take the derivative, and anytime you take the derivative of y, you have to have a dy dx. Okay? And so we're always going to solve for dy dx. So let's just do one really quickly. So if you have something like this, y equals x squared. That's a function, right? You know how to take the derivative of this. The derivative of this is take the derivative of y. The derivative of y is y prime, or dy dx, whichever one you like better. I prefer y prime. Derivative of y is y prime. The derivative of x squared is 2x, right? That's what we've been doing the whole time. Okay. Now, what's going to happen is our y's are going to get mixed into our equation. So something like this, number 1. We want to find the derivative. We're going to find dy dx for y squared equals x. Y squared equals x is not a function. That right there is a sideways parabola. Okay? Instead of y equals x squared, which is, what we just did, a regular old parabola, goes through 0, 0. This is x equals y squared, or y squared equals x, and this is a parabola going this way. It is not a function because it doesn't pass the vertical line test. All right. So let's take the derivative of this. Here's what you do. You take the derivative of y squared. In order to take the derivative of y squared with respect to x, you're going to take the derivative of y squared, which is 2y, and then what you do is you tack on a y prime. It's chain rule. The derivative of y is y prime. So you take the derivative of y squared, which is 2y, times dy dx. The book uses dy dx. I use y prime. It's up to you. Equals the derivative of x. What's the derivative of x? It's just 1. And so what is dy dx? Well, now we have to solve for y prime. Divide both sides by 2y. The derivative is 1 over 2y. And that's your answer. Okay? So if you don't understand like what's going on, and oh my gosh, this is so hard, Just remember, when you take the derivative of y, you need a y prime, okay? So let's do another one. Number 2. Let's do a circle now. Circles are not functions, okay? Here's a circle with radius 5, centered at the origin. X squared plus y squared equals 25. Do you recognize that? We did an entire chapter on conic sections in Algebra 2. In Ham, we did conic sections also. We're going to take the derivative of this, okay? So here we go. The derivative of x squared is 2x. That doesn't change. That's simple, okay? Now, the derivative of y squared is 2y times y prime. If you want to use dy dx, you can. You don't have to. Equals the derivative of 25, which is 0. Derivative of all constants, 0. And now we need to solve for y prime. So subtract 2x to the other side. So we have 2y times y prime equals negative 2x. So subtract 2x to the other side, and then divide both sides by 2y. I get negative 2x over 2y. And so then the derivative would be negative x over y. Okay, now, what do we need that for? Well, it's to find the slope, or it's to find the tangent line at any point. So if I say to you, now find an equation for the tangent at the point 3, negative 4. We can do that now. To find an equation of the tangent at the point 3, negative 4, well, we have a point, and now we need slope. And how do we find slope? We use the derivative. What's the slope going to be? Yes, good. So it would be negative 3 over negative 4. See, now the derivative contains x and y, but we have x and y. We just plug them both in. And so the slope would be 3/4. And so we get that our equation of our tangent line would be y plus 4 equals 3/4 x minus 3. Okay? So what we just did graphically looks like this. We have a circle. Oh. Let me try that again. We have a circle. That's worse, huh? How are you at circles? Pretty good? Whatevs. Okay, so there's our circle, and let's say that this is 5, radius is 5, and the point is the point 3, negative 4. 1, 2, 3, 1, 2, 3, 4. So there's our point. And the tangent is that line right there. It goes right along the circle, and that's the equation that we just found. That is the equation of that line. We can do it on circles. We can do it on anything. So it's called implicit differentiation. Let's try another one. It's really not that bad. You just have to remember to do y prime whenever you take the derivative of y, anything with y in it. Okay, because you're taking the derivative with respect to x. So when you take the derivative of, let's say you take the derivative of y. Derivative of y is 1, but y prime. The derivative of y is y prime. So you always are doing that. You were doing that all along. You just didn't know you were doing it. Like, what's the derivative of x? It's just 1, right? Derivative of x is 1. What's the derivative of y? Y prime. So you were doing it all along. You just didn't know it. All right, so here we go. We're going to find d squared y dx. That's a fancy way to find the second derivative. Okay? This is just find y double prime. All right, so we're going to be given something like this. X squared plus 4y squared equals 16. That's an ellipse. It's not written in standard form that we're used to. If it was written in standard form, everything would be divided by 16, and it would look like more like an ellipse to you. But that is an ellipse, and we want to find the second derivative of that, okay? All right, so buckle buckle up. This one's a tough one. So here we go. First thing you're going to do, find the first derivative. Okay? So we're going to use implicit differentiation. That's what it's called when y is in the mix. When you have y equals something, and it doesn't have another y in it, it's just y equals something in terms of x, that's just derivatives. That's just finding the explicit differentiation. When y is in the mix and it's not a function anymore, it's called implicit differentiation. All right, so take the derivative of x squared and you get 2x. Take the derivative of 4y squared and what do you get? 8y y prime. And this is equal to 0. Oopsies. 0. Yeah?
Wait, why is it 0?
Derivative of 16.
Oh, okay.
I know, I just wrote 16 on accident. Yeah, the derivative of any constant is going to be 0. Yeah, you're finding the derivative of all the different parts. Okay, so now let's solve for y prime. So subtract 2x to the other side, divide by 8y. So the first derivative is going to be negative x over 4y. That's the first derivative. Okay, that'd be nice if they stopped there, but they didn't. They said to find the second derivative. So here we go. To find the second derivative, we have the first derivative equals negative x over 4y. So now let's find the second derivative. Second derivative is the derivative of the first derivative, right? Yes. So we're going to do derivative of y prime is y double prime. And now we have to do quotient rule. Quotient rule here. Okay? So here we go. We're going to go low, d high, minus high, d low. Now what's the derivative of 4y? 4y prime over the square of what's below. Okay. So now we got to fix all this. Are you ready? You're going to be amazed at how this fixes. All right, so we have y double prime equals, I have a negative 4y plus 4xy prime over 16y squared. Is everyone okay with my algebra skills? There? You followed that okay? There's a negative moved out front, negative, negative makes a positive. Okay, so now we can't leave it like this. We have this y prime here, and we're going to substitute what y prime is. Okay? So we have negative 4y plus 4x. And what was y prime? Y prime is negative x over 4y. And this is all over 16y squared. Okay, so I replaced y prime with what y prime is.
Can you not drop the 4y to 16y squared?
No, there's a plus in the middle. The only time you can reduce things is if they're factors.
No, I mean, like, can it, where it says negative x over 4y? No, yeah, you can't bring it down.
No, because it's times just this. We could reduce everything by 4 if we wanted to, but we're gonna do a lot more. There's a lot more to happen. Okay, so here we go. We get negative 4y. This becomes negative 4x squared over 4y. And this is all over 16y squared. All right, so you're not allowed to leave fractions inside of fractions. That's really bad. What we're going to do, where'd that 4 go?
Yeah.
Oh, we can reduce that. There we go. Is that better? We have a 4 over 4. Okay, let's rewrite that.
But you don't have to put this on.
No. No, you can't because there's still this. This is all up top. You can't just move that to the bottom.
I'm not talking about that. I'm talking about the bottom of the fraction.
Yeah,
On top.
she said you can't because there's still 3.
Yeah, if they both had a y, we can move it to the bottom, but they don't. Oh, no? Okay, so how are we going to get rid of our fractions over fractions? Let me tell you like a little shortcut, easy way. See, there's this y that's bothering everybody here. what we're going to do is we're going to just go ahead and multiply top and bottom by y over y. You're allowed to do that. It's fine. So you take that y and you distribute it to both, and you get negative 4y squared minus x squared over 16y cubed. Okay, so we fixed that. That's great. That's nice.
And the y's reduced?
Nope, the y's can't reduce because there's a minus here. If this had a y in it, then yeah, you could reduce. But this, I'm going to show you one last thing, one little trick here for these problems, and this is what happens. Let's factor out a negative 1 out front on the top, and I'm going to rearrange these. We have x squared plus 4y squared over 16y cubed. Now, go back to the very original problem that we started with our ellipse that I gave you. Do you see something there?
Yeah.
What do you see?
The count times everything is the same.
Right here. X squared plus 4y squared equals what? 16.
We're substituting it for 16. Right?
Yes. Go back down here. What do I have? I have x squared plus 4y squared. What did we say that was equal to? 16. So I have negative 16 over 16y cubed, and that reduces to negative 1 over y cubed. That's the second derivative.
Oh my goodness.
Crazy, huh? Yes. Those happen when you take the second derivative of ellipses, of circles. It happens all the time where you can go back up to the very original equation given to you and substitute it back in. Did you get math goosebumps from that? Totally, right? Did you just throw up all over your desk? I'll have to do some cleaning up at break today. What number was that? 3? All right, number 4. Whew. A few more, just a couple more. Okay, so we've done some so far. They haven't involved, like that second one was hard, or this last one was hard because we had to find the second derivative. But let's say we have to find dy dx, and it's going to involve product rule, okay? So let's say we have, or not product rule, chain rule. We'll do product rule next. We'll do chain rule now. 2y equals x squared plus sine of y. Okay, gets pretty complicated when you have multiple y's here. Not only that, but you have a y inside of a trig function. It gets a little crazy, okay? So let's take the derivative of 2y. What's the derivative of 2y? 2y prime. Okay, don't forget, 2y prime equals the derivative of x squared, 2x. And now this is going to be chain rule. There's an outer function, which is sine, and then there's an inner function, which is y. So let's take the derivative of sine y. Derivative of sine y is going to be cosine y, and then times the derivative of y, which is y prime. Okay? All right. Now I have to solve for y prime, and I have more than one. So let's get our y primes over to the same side. We can just move them over here. Okay? So I have 2y prime minus cozy y prime. So cozy. Equals 2x. So I'm getting all my y primes together. And now I can go ahead and factor a y prime to the front, leaving me with 2 minus cosine y equals 2x. And then finally, solving for y prime, we just want to divide. So y prime equals 2x over 2 minus cosine y. And that's it. Okay? The slope is undefined somewhere. It's undefined at 2 minus cosine y equals 0, but I'm not going to worry. We're not going to worry about that. All right, let's do a product rule. Okay? So we're going to find dy dx or y prime, whatever you prefer. I think the book likes to use dy dx more. I kind of like y prime. Find y prime for x cubed y equals y. And these things are going to get complicated. We're finding derivatives of non-functions. All right, so this is product rule. You see the product? It's right there. It's x cubed times y. So let's go ahead and take the derivative, okay? So it's like saying this is a and this is b. So we're going to go a times b prime. What's the derivative of y? Y prime, okay? Plus b, which is y, times a prime. Derivative a prime? 3x squared. Equals the derivative of y, which is y prime. You're getting the hang of these, huh? Takes a little while, you know, learning anything new, it's tough. Now let's get our y primes together. So I have x cubed y prime. I'm going to subtract this y prime over to this side, and I'm going to get rid of those guys over to that side. You know what, I'm going to rewrite that as 3x squared y, if that's okay with you. Do you see what I did? I just rearranged some stuff. I brought this guy over to this side while taking this one over to that side.
So does that one have to be negative?
Yes! What am I thinking? Yeah, it's negative. Thanks. Okay, so now let's go ahead and factor out a y prime here. So you factor out a y prime and you're left with x cubed minus 1 equals negative 3x squared y. And then finally divide so that you get y prime equals negative 3x squared y over x cubed minus 1. They might ask you, where is this undefined? The tangent, it would be at 1, because you can't have 1 in the denominator at x equals 1. All right, and then the rest of this lesson was just on fractional exponents, but I've already been doing that with you. So we're just going to do one. It would be something like if you have to take the derivative, if you have y equals the cube root of 2x plus 1. Okay, we've been doing these. What's that? Uh-huh, yeah. So we've been doing these. They show up in this lesson because they think we haven't been doing them or something, but we have. So yeah, I would rewrite this as 2x plus 1 to the 1/3. The cube root is to the 1/3 power. And then this is going to be chain rule. You want to try it? You want me to? Yeah? Okay, I'll let you try it. If you can't, that's okay. Just wait for me and I'll do it with you. And no negative exponents in your answers. Are you confident? Confident in your chain rule skills? So you bring the 1/3 down, and then you want to subtract 1 from 1/3, which is what? Negative 2/3, yeah? Times, yes, that's the part people forget. Times 2. All right, so let's rewrite this. So we have 2/3. It's kind of written gross. And then that on the bottom, you would drop that down, 2x plus 1 to the 2/3. I'm okay with that answer. Some professors might want you to rewrite it as the cube root of 2x plus 1 squared. That's what to the 2/3 is, but I'm cool either way. Either of these two answers. Okay? Did you get it? Yeah? Good.